Okay, so let us go ahead and get ourselves started today. Today what I'd love to do is kind of just keep on going with the example that we started last time of panelizing a surface and having it start to react a little bit to the sun, and to kind of take that a little bit further, saying that, hey, not only do we want to go through and be able to kind of orbit around different types of geometries to get them to face things in the sun, but we'd actually like to be able to get the panels to be able to respond to the location of the sun, doing things like changing the instance parameters so that we change the size of an opening or change the directionality of a fin or the length of a fin, something like that. Just something that's happening in response to the actual physical environment, and get those things working together. And even provide a little bit of visual feedback on like what the strength of the sun hitting that surface is, by providing some little color feedback, which is often a very good way of understanding kind of how strong the effect is. So we're going to start by basically picking up an example from last time and continue with it a little bit, just try and get it to go and respond a little bit more to the environment. And then for the second part of the class, we're actually going to kind of start a new project where we will kind of start creating a new stadium design that would be based on kind of some geometric parameters that we could start changing and tweaking in Dynamo, that actually have most of the elements of the Revit design actually dropping out or coming out of the curves that we're defining within Dynamo. Okay, so two different things we're up to today, kind of heading in that direction. Any questions as we get going? In pretty good shape? Okay, if you would like to go ahead and get started and follow along, please download the Session 7 Dynamo Examples.zip and put that on your machine. That it has all the intermediate files and some of the part files that we're going to be working with. Okay, most of the stuff we'll just be creating here on the fly, but if you want to sort of follow along and kind of have a place to fall back to, that's a good file to go ahead and get yourself started. So with the overall script in terms of where we're going to be going today is kind of indicated up here on the board in terms of looking at the sun path location, and then really trying to go through and use a series of different functions to figure out really what is the plane that best describes the surface of all the different panels, and then for that plane, really how far away or how off is it from the relative angle of the sun? Okay, so is it facing the sun or is it very kind of oblique to the sun? So we're going to use a couple of different functions to do that. Based upon that directionality and our assessment of how close it is to being facing the sun right now, we're going to go through and do a little scaling. We're going to figure out sort of what's the highest or the most directly facing the sun, what's the furthest away from facing the sun. So we have sort of just a notion of what the high end of our range is and the low end of our range. And based on that, we're going to go through and start resizing the openings like on these different surfaces. Okay, so that if you're facing the sun the most directly, we may give you the smallest opening. If you're facing the least amount of the sun, the opening will be much larger. So the idea is to go ahead and provide a little bit of shading where it might be the most useful for us. Okay, so that's kind of the overall script of where we're going to be going. And in terms of opening this up, you could go ahead and open up. This is actually where we ended up last time. So this is that same example of just panelizing, and based upon both the number of ribs we wanted to put in and then the number of panels within each of the different bays, it created this. And this was done with this funny little part called the aperture panel. And if you take a look at that panel and you say that you want to edit it, you can see that it's a adaptive component. It really is defined by 4 different points that indicate how it's going to be placed on the grid. There's a couple of variables in there: wall thickness, okay, that we can start messing around with. Okay, that's just sort of indicating the height of little triangular ridges. But we're going to actually kind of open up a different part that has more control for what I'm interested in. So I'm not really so concerned about, for this example, varying the depth of that wall thickness. Yeah, I'm going to be playing around with the notion of just the opening itself. Okay, so we're going to open up a slightly different adaptive part. And if you want to take a look at that part, please head on out to the example. You'll find there's an adaptive components folder, and within there, you'll find this panel with a resizable opening. Let's just take a look at it for a second, see if we can size it up and figure out what's going on with it. So I'm going to rotate that around to 3D. This is actually a fairly simple component. It's pretty much just based on a rectangular grid. Okay, but based on that rectangular grid, it's kind of offset from the grid a little bit. Yeah, here are the 4 different placement points. Yes, what is that? That's 0.1. That looks like that's 0.4. So 1, 2, 3, and 4. And you'll see it's made up of a series of different little panels in there. Okay, and within those panels, there's this notion of an opening. So what's going to happen is we're going to be able to resize that opening, okay, based on the instance parameter we're going to put in there. Okay, and then as we change that instance parameter, that opening is going to get smaller or larger, kind of very much like a window opening does. Something like that. It's just sort of defined within here. And let's see if we can kind of just size up this part a little bit and kind of figure out how it works. If we take a look at what the parameters are, there's sort of a thickness. Okay. We can figure out what that applies to. I imagine that actually applies to the whole notion of how thick that is, just from the front to the back. Then there's this notion of an opening and some sort of ratio, and let's talk about that and see how that sort of plays. So if I go through and I put in, looks like the default value is around just under 0.2. If I put in a value of 0, let's try that and see what happens. Okay, looks like I can't do that. Let me try something very small, like 0.01. Oftentimes as we're working, things don't like to be 0 width, and it's complaining about that. Okay, looks like 0.01 gives us a very, very narrow kind of opening. Let's kind of scale it up to the other end. Let's go up to like 1. And you'll see it's going to get a very small opening. Okay, it turns out actually there's a little bit of intelligence built into this part itself in that although I've put in the value 1, you can see it actually isn't using 1 right now. It's actually using something called a variable opening govern. And opening govern is really, it's just sort of based on this formula. So basically, it'll allow us to get up to 0.45, but if it gets to be more than 0.45, it's just going to stop and use 0.45 as the cap value. Okay, and that's because it looks like the way this is defined is, I'd sort of interpret it as it's the proportion, between, like the outer edge and the inner edge. We can get up to about half the distance, but we can't get any greater than half the distance, then it would start overlapping on itself. Okay, and just to allow that there's any sort of opening in there, it's not letting us get up to the full 0.5, it's only letting us get up to 0.45. Okay, so that's just sort of to understand the scaling of what we're dealing with. So we have this panel, and we're going to put in a value here somewhere between like 0.01 and 0.45, and within there, these little openings are going to go ahead and scale themselves. So, get an idea of how the part works? Okay, beautiful. Okay, if you got an idea of how that part works, let's go ahead and do this. We are going to take that part and load it into our project, and we can do that a couple of different ways. We could go ahead and just say load into project right up here in the upper right hand corner. And if you do that, it'll sort of show you the list of the open Revit projects. So I can pull that right into example 6.2. The other way to do that is I can just close it and go into example 6.2 and just load the family. Either way, it kind of has the same effect. This is really just a shortcut for doing that. So I'll do it the longer way. I'm going to just close up this panel. I'm going to say, no, don't save any changes. I'm going to close up that other panel. So here we are. We're back in the project file now. And if I want to be able to enable that so that I can use it, I'm going to say insert, load in that family, and go on out and find it. And I think it is under session 7, Dynamo Examples, Adaptive Components. Okay, you'll find it right there. Okay. By default, it's not doing anything. It is put it into the project here, panel with a resizable opening. That's looking pretty good. It's available to us here. But at this point, it hasn't really made any changes in the geometry. I could go ahead and start using it in the geometry. I could go ahead and replace that manually. Again, if we manually override things from Dynamo, it's okay. It'll let you do that. I could say, let's do that with a panel with resizable opening. And you'll see there it is kind of hanging out in there. And you can even sort of test it here, again, just to get a sense of how it works. It's an instance parameter, so anything from 0.01, which would be next to nothing, all the way up to, again, 0.45 is the cap, but if I put in 0.5, for example, okay, it'll cap it off. So we just have something that we can start changing just the amount of coverage that each of the panels is providing. So in terms of using this, okay, I just replaced it manually in that one place, but if you would like Dynamo to kind of put it all over and panelize it, we could just sort of swap out the types. But if we want to use the script to do that, let's go ahead and we will start with, I'll go back into the add-ins and let it go ahead and place those for me. Okay, and I'll open up, and for this one, I'm going to go to the Session 7 folder. Dynamo Examples. Let's say panels reacting to the sun location. Let's just use the start. This is actually almost exactly the same as where we left it at the end of 6.2. About the only difference here is I've gone through and put in under select family type, just go to this panel with resizable opening. And if yours doesn't say that right now, go ahead and pull on down and grab that, get that panel with this resizable opening. Okay, and from here on forward, it ought to pretty much run the same. Go ahead and say run that. And what this should be doing now is replacing all those openings. Now, I think that what I actually have going on here, just so you can sort of see, I think I actually have two instances kind of hanging around here. I have actually one instance that's sort of severed from the Dynamo scripting right now because I went through and did that manual override. Let me see if that's true. I'm just going to try to test this. I'm going to take out that panel. Let me try regenerating them again. So I can put one in that's still controlled by Dynamo. There's definitely this very weird thing about when elements get severed from the Dynamo scripting and they're no longer working, and then I think they're just operating independently. Okay, now it's back in there doing it the way we wanted it to. Okay, so you can play around with this if you want. You can go ahead and change those instance parameters if you want to on all those things. You could try changing just the fineness of this whole grid, just kind of using the same scripting we did last time. So for example, if we wanted to go through and just either change the number of ribs or change the number of panels in each of the different bays. Right now there's 5 in there. Let me just kind of pop it up a little bit. I'll say there's 8 of them there. Maybe 8 there. Let me go ahead and run that again. Now, let's go ahead and talk about this issue of running, not running, and just the speed with which all this operates. Because what happens is, pretty quickly as you're working with complex surfaces, complex forms in Revit, the overhead of every time you make a change, having it go through and regenerate that change gets to sort of be painful in terms of what's going on. So we can go through and kind of put in a variable that will help us out a little bit. What's going on in here? Looks like my ribs are still a little bit off right now. What do I have to do? I changed the spacing on that, but I did not change the spacing on the ribs. Oh, there's the new ribs. Hang on, they're there. They're underneath it. I got these old ribs that are still hanging around. I'll get rid of those. Yes?
Whenever you have old stuff just hanging around, is there any way to delete them without having to do it manually?
What I tend to do that seems to work the best, not programmatically, because it's just sort of, it's not considering itself to be part of the same thing. The best thing to do really is just kind of select it all and filter if you can. You know, what's going on. That'd probably be the best way to do it. And then, again, just go back and rerun it to regenerate it. That's kind of, I would want that, right? Yeah, that somehow, severed object, please go ahead and regenerate yourself. let's talk about this issue of just the geometry and how we can control whether or not the geometry regenerates versus just allowing us to kind of tweak around in the geometry and start playing some things. And there's actually a very simple way to do that. It involves putting on this little if condition in there. Let's just talk about that. Here's the deal. All the geometry is really created right back here at the tail end where we say that we're going to do adaptive component by XYZ to create the ribs, adaptive component by XYZ to go through and create the panels. Okay, so what's happening is it's creating all those things because it has X, Y, Z, Z's that are sort of popping into it. Okay, so if you want to go through and control that and give yourself a little switch to turn on and off, here's what you can do. One of the different types of elements you can create is called a Boolean. Okay, and a Boolean is just true, false. I'm just going to pop that up a little bit so that I can see. And for the Boolean, let's go ahead and put that in there. Okay. Let's go through and just create something up here. We'll give it a new name that's a little bit different. Let's just call it just update the Revit model or update Revit geometry, whatever you want to call it. So what we'd love to have now is based on this value, 0 being false, 1 being true, we'd love to have something that either if it's false doesn't pass the geometry or if it's true does pass the geometry. Okay, and we can set something like that up just using a simple if condition. So if we put an if in here, there's this notion of a test. So let's feed in the value of either 0 or 1 as the test. Okay. If it's true, what I would love to do is actually feed in these XYZ values. Okay. If it's false, however, what I'd love to do is actually just pass it an empty list. I don't want to really give it anything. So to go ahead and allow for that, we can actually use empty list. Okay. And now, based on the value of true or false, okay, it's going to go through and either have a list in there or not have a list in there. Let me take the result of that and feed that in, okay, to the adaptive components. So what's going to happen now is because it says false, okay, to the adaptive components for the panels, okay, I expect that it's not going to generate the panels. Let's go ahead and try that. Looks like it's complaining, doesn't like an empty list. Looks like over here, they're still hanging around. It doesn't delete them. That's really interesting. Okay, let's go ahead and test that though. Come back over here. Get rid of all those. Get rid of that one too. Let's try running this again. Okay, because, that's an interesting one kind of hanging around in there. Because the panels are turned off, oh, it's interesting, it's putting 1 just at the 0, 0, 0. That's interesting. It is placing 1, but it's placing it in kind of a funny spot. It's just kind of putting it down there on the floor. Surprises me, but we'll let that be. Okay, we can go ahead and decide whether we really want to update the panels. If you wanted to, you could use the same sort of notion in terms of updating the ribs. We could put in a separate switch for updating the ribs, or just do the single one for updating the ribs, really whatever you want. Let me go ahead and, I'll put that same sort of logic in here. I'll put an if down in here. Again, a Boolean. This is going to be rename that. I'll call it just update the rib geometry. Or ribs in Revit. Again, put that if in there. Give myself an empty list also, so that, and again, I could copy and paste these down. I'm just kind of doing it the slow way, so you can see where they're all coming from. So the false will be the empty list. The true will be the sliced list of points. The test is right here. And the result, that'll pass to be the determining point for where the ribs get placed. And I can turn that off too. So again, I can take these out. Okay, now theoretically no ribs, no panels. Okay, so at this point, if I run, okay, or even if I run automatically, the deal is it ought to move pretty quickly now, since it doesn't have to go through and do the generation of the geometry in Revit. If I just want to, and let's talk about why this is useful. This is useful, whether you're doing the XV UV grids or you just want to sort of see what the points are in the quads, all that kind of stuff. The idea is, I can now go through and adjust those things and really quickly, almost immediately, kind of get the points. Even though it's not generating the geometry, the computation of those points is very, very quick. So it's useful for debugging to be able to turn that on and turn that off. Just because as you work and your model gets messed up, your points may not actually generate valid geometry. So rather than having Revit complain at you, just kind of turn it on and turn it off when you want to. Okay, so that's all just getting ourselves started. We got these planes that are looking pretty good. Let me go through and I'll turn back on the adaptive panels because I do want to see those. And I'll run that. Okay, because we're going to work with those panels. And what we want to do is basically fit a plane to them and then do some sort of calculation that says, hey, relative to the sun, where the sun is right now, can we go ahead and just figure out how aligned or how far apart those two different vectors are? And based on that, go through and do a little bit of scaling. Okay, so let's just kind of look at it in the background for a second, and we will keep on going. Got my panels, they're all looking pretty uniform back there. Okay, so we're ready to move on to the next step. Okay, people good? Okay, excellent. If you have that, let's start with the whole notion of this best fit plane and how we work that. And the idea is we have these planes that are actually defined by these quads. Okay, these quads of different points there. And what we love to do is actually just sort of fit a plane to those. Now, while we're thinking about fitting a plane, because let's talk about why you need a best fit plane. Because the surface actually sort of curves in two different directions, and there's 4 points that define it. Okay. We can't actually just sort of put a normal to the curve because it sort of would be where is it on the curve. So what we're doing here is we're just approximating that by just making a flat plane, like out of those 4 different points. So just a completely flat surface. Okay, and then relative to that, just saying, great, we want to compute a normal that's perpendicular to that. Okay, just so we can sort of figure out really what is the normal to the surface at that point. Okay, so that's what we're after here, is really trying to approximate the curved surface with just a normal to, the best fit plane. Okay, so that's what we're after, and let's kind of do it. It starts with this notion of best fit plane. There's best fit line and best fit plane. Looks like all it wants is a series of X, Y, Z's. So I can give it the quads. 4 points to do that. Actually, 3 would do it. Okay, and it creates a whole series of different planes for us. Okay, so we have a couple of different things that are sort of available to us now. We have the plane itself, the normal to the plane, the origin of the plane. We have a lot of information that can come out, and we're going to go ahead and use that stuff. Okay, so what we are going to do is go ahead and try to use that normal, okay, with the notion of where the sun's position is. Okay, the sun's position we haven't really defined just yet, but we can go ahead and do that. In terms of the sun position, Let's go ahead and say sun path direction. Notice there's no sun path registered just yet. That's kind of okay because we haven't turned anything on in our model file. So let's go ahead and do that now. We'll go to the model file and turn on the sun path and just give it some location in the sky and see if we can bring these things together. Okay, so coming back over to Revit in the background there. Just shrink it out of the way there. Let's turn on the sun path. Okay. Let's even sort of be explicit about where it is. It's kind of hanging around right in there in terms of the sun. We can go ahead and move it around a little bit. Okay. But in terms of how this is going to work, when you say sun settings, right now I have something called the in session still. I've moved it around manually. It's not at one of the predefined locations. If I wanted to really go for summer or spring or winter, either the solstice or the equinox, I could choose a specific point in time it would report that. If I've just sort of arbitrarily moved it to some point, that's just kind of called in session. It's just some place that I've put together. Or I could even give that a name if I want to. Okay, but we're going to go through and, now let me show you where that is. So for example, here it is. It's just sort of like mid-morning or something like that. If I wanted to go through and get the name, use shared settings, save the settings. I can give it a name right there. So I could say, oh, this is just sort of my mid-morning test point one. And it'll put it in the list there. That's just kind of, if you want to be able to get back to things very regularly. And I'll say okay to that. When I come back over to Dynamo, okay, say use the sun path from the current view. What it's going to do then is go through and just report that for us. See what it's complaining about. Have not been selected. I believe we have. I'll try running that again, see if I can get that to update it. Click to pick the sun and shadow. It's confusing me because I think that has been done. Let me go through and do what I tend to do when nodes aren't working the way I want them to, which is when I think nodes are confused, I tend to go through and just put them back in again. I'm still not doing it. That's kind of interesting. Empty there. Yeah, I wonder if it's complaining just because it doesn't like my like arbitrarily named one in terms of doing that. Let me just do a little experimentation here. Let's actually just go back to the equinox or something like that. And let's say the summer solstice. Okay, sun high in the sky. Interesting. When I came back, it actually was. Okay. In the spirit of debugging, you has different sun paths. Now it seems like it likes it. A little unclear to me about like why it likes it sometime and why it doesn't like it sometime. Okay, we got this plane. We got this notion of the sun path location. It's time to start getting those things together and figure out really how we can make that work. Okay, so what we're going to do is as follows. We're going to use a function called direction to XYZ. And let's talk about what direction to XYZ does. That takes two different vectors, and it actually sort of figures out really what the difference is. Calculate the normalized vector from one XYZ to another. Okay, so from the path where the sun is right there, okay, to where the best fit plane is, and let's try this. It's going to be The sun is going to be the end. The start, I believe, is going to be the plane itself. Okay, and with any luck, see what it's saying in here. It wants an XYZ. I must be tying the wrong thing in. I think it's got to be the origin then. Great. Okay. So what it's going to be giving me now is a whole series of different just direction vectors that are going from basically all these different planes back to the sun. So it's just going to go through and from each of these different things kind of figure out, you know, what that path is. The normalized vector from one XYZ to another. Okay, so from this point to that point, it's the normalized vector between the two. Okay. Once we have that, we are ready to go through and look at something called the XYZ distance. If I can spell correctly. Okay. Returns the distance between 2 points. And this is the part I have to think about what I want in here. I want the starting XYZ and the ending XYZ. And what I think I want here, we'll go ahead and save this in progress. I gotta think about the variables that I want in here because it's like which one's which is always the one that I want to sort of get myself confused out of in terms of what's going on. So I'm thinking I want the direction up to there. Then for the best fit plane, I think I want the normal vector. Actually, I think it'll probably work out either way because it's just going to create, it's just some distance between the two different vectors. Okay, and what that is going to do is return a list of different values. .6, 1.5. Let me just try to test it the other way. I'm trying to think about it really whether it has an impact on the distance. Yeah, let's try putting the normals up here. No, looks like it's the same. It's just a distance. Okay, I'll handle that. 1.6, 1.5, 1 or 1.58, 1.52. Try it again. Yep. Okay. Looks like it didn't make much of a difference. Okay. Once we have this big list of all the distances, and what this is what it considers to be the distance between like the normalized vector or the distance to the sun and the normal. So it's computing some distance there. Okay, what we really want to do is now do a little bit of scaling based on that. And to do that scaling, here's what we want to do. We want to take that list of all these different distances and really, okay, ultimately we're going to have to come up with a value between 0 and 0.5. Okay, that's the scaling that we're going to use for the aperture. So what I want to do is actually do this. Go through this list and kind of sort it out, figure out what the high and the low is, just so I can figure out what the range of values is, and then scale all of the different values about where they are between that top and that bottom. Okay, so let's sort of think where that goes. So if I look at this list, you'll see it's everything from, I see 1.79, 1.6, 1.5, 1.47. Okay, a little bit hard to kind of deal with in this form. So we're going to actually use a sort function, and the sort function is going to let us go through and put that, what appears to, well, it's the list in the order in which the panels are created, okay, and we're going to go through and sort that out so that it actually has a little more order to it that's useful to us. So I'll say sort, and let's feed it a list and see what happens. By sorting the list, what we actually do is we take all those XYZ distances and we get them in an ordered list that says 1.39 all the way down through 1.8. Okay, so that's the range that we're working with. Okay, once we have the range, we can sort of figure out, okay, I want to scale things, what I need to do, what I'm ultimately trying to do is, okay, let's think about this. We have a bunch of X values, okay, going from 1.39 all the way down to 1.82. Okay, this is kind of the range. What we want to do is basically just do an interpolation between those things. So what I'm interested in doing is basically saying, okay, if this is the low, and that's the high, what I want to figure out is really where is any individual value relative to the low and divide it through by the difference between the high and low. Okay, so what I'm going to do is basically construct a formula that looks like this. I'm going to say x minus the low, that'll give me the height above, okay, and then I'm going to be high minus low. Okay, and somehow that'll give me some scaling between where we are between the highest and the lowest values. Okay, so that sort of makes sense? Okay, because really all we're trying to do is, what I want to come up with is the highest one should come up with a value of 1, the lowest one should come up with a value of 0. Okay, so this is going to return anywhere from 0 to 1. So this is just kind of a big scaling factor. Okay, and let's go ahead and see how that would look. Okay, to take a list and figure out what the first and the last, or the highest and the low values are, here's what you do. You say first of the list, and you take last of the list. With those two things, I can take that sorted list and fit it in here. So let's take a look at that did. Low first of the list seems to be 1.39. That looks pretty good. Last of the list, with any luck, is going to be 1.82. Excellent. That's looking pretty good. Okay, so understand where I'm going with the high and the low, stuff like that. Okay. We now want to go through and construct a formula that's going to relate all those different things together. So let's talk about how that's going to work. Okay. The formula function, which we've learned a couple times ago, is a very useful all-purpose function. Shows up in red, which makes you panic a little bit because it looks like it's having troubles. But the trouble it's having is that we just haven't defined what the formula is that we want to put in there. Okay, so can someone suggest a formula to me? Go ahead and you describe it any way you want to, and we'll go ahead and hook things up to it. So if we want to go through and create this formula, suggest your own variable name. How do you want to write this thing? Anyone? Petrush, you have an idea. Okay, so A minus B, okay, divided by C minus B. Let me put all the parentheses in. Okay, and out of that, you'll get sort of, it'll sort of just populate that with all the values that you want in there. Okay, if you wrote it very, very efficiently. I tend to write things in a I'm very bad. I write them in very verbose ways, which makes them very easy to follow later. Okay, so what is your B? Your B value is, okay. Okay, then we'll change it to low. Okay, and what's your A value? That's the X of the individual point, okay. And really, and with that one, that's the high? Yeah. Fantastic. Again, whatever works in terms of, I just tend to write things in very verbose ways because I can't remember what I did tomorrow. It's just one of those things. Okay, so let's kind of hook these things up. We'll go through and grab that first of the list. That's my low value. I'll grab that last of the list. That's my high value. Drop them on in there. Feeling pretty good? Okay, we need to give it the X points itself, and let's talk about the X points itself. for the X points, there's a number of ways we can do that. Really, we should be able just to grab these guys right here, or actually those guys right there, the unsorted list. As I was playing around with this, I made the mistake of grabbing the sorted list and putting that in, and of course you get a perfectly linear function then, which is not what you want. What you want to do is, you want to get the list of points, okay, in their original order, because that is the order to which they map to the faces, okay? So what I want to do is get that list of different distances and grab it and pull it in there. Okay, and let's take a look, see if we're doing any good here. Okay, so it looks like based on this formula, we have some relative strengths, everything from 0.5, 0.40, kind of hang around over there, all the way down up to 1. So we have something that's evidently really closely aligned to what's going on. Going all the way back down to we have some that are even at 0 or close to 0. Okay, so we got a lot of stuff hanging around in there. I guess the 1's my high point, the 0 is my low point. That's how I should interpret that. And everything else is just somewhere in between. Okay, looking pretty good. Now, for each and every panel, I have a numeric rating. So for how high the strength is, what the strongest one is, what the second strongest one, and kind of going on down the list. We're in pretty good shape. We are ready to start mapping this now to some sort of attributes of the function, or the panels themselves. Okay, so let's talk about that. Okay, in terms of the mapping, currently we're going 0 to 1. Okay, in terms of this formula for converting the strength into the size of the opening, okay, scale of the opening, okay, yeah, we need to kind of change that a little bit. We need to basically go from a range that goes 0 to 1 to, you want to go anywhere from, oh, it's like 0 to 0.45. Okay, that's the range we want. Turns out if it's 0.5, that's okay. It's just going to stop it at, actually, if we feed it 0 to 1, what's going to happen is anything above 0.45 will max out at 0.45. That's what the function, that's what the parameter does. We're trying to go from somewhere like within this range here. So, any suggestions? We need a formula that's going to go ahead and map those into that. So let me even going to go through and rename this just so that we have a nice little gnome in here. This is really going to be the strength of alignment. This is 0 to 1. Just because I like to leave things around so I can really tell what's going on. Okay. Now I want another formula in here. Okay, and this is going to be strength scaled to values. Opening values. Okay, I'm looking for something that's going to take 0 to 1 and give me 0 to 0.45. Any suggestions? What's that? Oh, we can use this if you want. Yeah, let's talk about how you want. We can use this. Suggest something. I see a simple way to do this, but tell me what you're thinking. Oh, okay, we could do that. Yeah, the approach you're suggesting is to put like a cap in it, put a limit, a ceiling to it. So anything below 0.45 will just return the true value. Anything above 4.5 will just return 4.5. Okay, we can do that. No worries. Yeah, that's one way to approach it. I'm thinking about just linearly scaling it. Yeah, again. Yeah, that's the simplest way. Yeah, it's really, again, we could do all sorts of things. We could have a nice linear transform. We could put like an exponential transform in there if we really wanted to accentuate the high points and, really differentiate the hot spot versus the cooler spots. We could do it a lot of different ways. But the simplest way is just, I'll just put in there just strength times 0.45. course, it helps if you spell properly. Actually, it's not really all that critical here, because what happens is, this node is smart enough, it's just going to take anything I give it, and it'll say that's the input value. If it doesn't recognize it, it assumes, oh, that must be an input value. Okay, so this is now returning a whole bunch of values going anywhere from 0 up to 0.45. Yes?
Is there a way to do it going?
Sure, let's see. Well,
I tried the common one.
Let's see. Hang on. Let's see. I'm thinking this will be e to the x. Yeah, so that's e to the x right there. The other thing would be, just in terms of simple powers, I think this will work. Like the strength squared. Yeah.
It actually uses the C++ script.
Ah, yes.
You have to type COW and then bracket A, B. So it will give you A raised to the power.
Oh, and is A the value and B is the exponent?
Yeah.
Okay, so if I like cubed all these things or something like that, it would be A cubed. That's much better. What I was doing with a little caret didn't work. It gave me all these funny integers. Do you know what the caret returns?
I don't think it works.
Okay, interesting. Yeah. It's just different enough from my Excel stuff that you're familiar with to be confusing, but okay. So it looks like POW for the power function. Excellent. Okay. So whether it's the cubed or the fifth or whatever it is. And this is something to actually sort of play with a little bit, because as we go through and we try to scale, it doesn't necessarily have to be linear. In fact, a lot of times when we're doing visualizations, it's helpful. An awful lot of times when we're doing like visualization of daylighting, or even of like the value of the strength of like the sunlighting, we do logarithmic things. We do things that sort of have a really sharp drop off, so that it's quite clear what the hot spots are versus the more ordinary ones that are kind of just average. Okay, but for now we'll just go for just the strength times 0.45. Looking good. Hopefully that's returning a whole bunch of different values in there, everywhere from 0.45 down to 0 at the bottom. Okay, we got a whole string of values. We are ready to use this string of values, so we're good. We're kind of right on down to here in terms of where I was thinking about going. We scaled it, kind of giving it a strength scaling, then we did a little downsizing. That's kind of scaling it down to the range of values that we're interested in here. We're now ready to actually go through and map it in to this adaptive component and use this thing. Okay, so let's talk about that. I've created all these adaptive components. They're kind of hanging around over here, this opening panel with a resizable kind of opening. That's looking good. I want to go through and take all of these different values and then use them to plug them in. So let's go back over to Revit and just kind of take a look at that thing, see what instance parameters are, just so we get the right value and kind of go from there. So what I will do is I'll come back over to Revit. Let's just zoom on in here a little bit. Let me grab that guy. Okay. So of all the different things we know about it, we can do a little interrogation and we'll figure out right over here from the properties palette that opening is just the name of the variable we're looking for. Okay, and it's going to be a simple mapping just based on that text string. So let's go back over and see if we can use that. So here's the deal. We're going to go through, and what I used to say was setting family instance parameter. Now we know it's just get element or set element parameter, a little more generic. Okay, let's do that. We'll say set element parameter. Okay, and let's talk about it. In terms of the elements we want to grab, what we're going to do is actually just grab all of those adaptive component panels, all those ones that are hanging around right over here. We're going to drag from the adaptive component and say those are the elements we're going to do the application of some sort of value to. Next up, we need to tell it which of the different parameters we're going to go through and adjust. So let's say that that is going to be just a string. We'll call it opening. Finally, we need to give it some values. And the values we're going to use are the values that we just scaled down from this whole function. Okay, so the strength times 0.45, that's going to be the size of the opening that we're going to go through and compute. So if we take that and we feed that into the values, okay, with any luck, okay, we're going to start having some changes. Now, this time, finally at this time, it's taking a while to go through and doing calculations, because what it's doing is, we finally changed something that's causing all the Revit panels to regenerate. Okay, so let it go through. It had to do a little calculation all over the place. See what's going on. Let's see if we can figure out what's going on here. So it looks like, based on the normals, okay, what is happening is, it's kind of interesting. Yeah. The way we've written it right now, actually the panels, which are sort of the most directly aligned, which have the normals which most closely align to the direction to the sun, they're the ones that actually have the most opening right now. And the panels, which are relatively oblique, have the least amount of opening. Okay, and that's one way to write the formula. The truth is, I might want to write it the exact opposite way. If I was thinking about it from a sun, well, this would give me the maximum sun, or kind of put the glass where it's going to do the best. From a daylighting standpoint, perhaps this would be best. Okay, because it's going to capture the most of the direct sun rays. From a sun shading standpoint, I might want to do just the opposite and kind of flip it around. So let's kind of think about that. Back over here in terms of the opening values, we could go ahead and say that as opposed to strength times 0.45, how would we flip it around so that 0.45 became 0 and 0 became 0.45? So how would we do that? Think simple arithmetic. Yeah, exactly. What I've learned about so much of this stuff is that often it's that simple math, that stuff, that really sort of works the best for you. So if I just say that is, I can get myself back over there, 0.45 minus, and I always put parentheses in just because it makes me a little more certain about what the result's going to be. Okay, this should just sort of reverse the behavior. I'm hoping, with any luck, so the 0 values will be 0.45, the high values will reverse themselves down to 0. Okay, let's check it out. Oh, looking better in terms of the shading sort of being the stuff that's most directly in line with the sun. See if I can rotate that around a little bit. So looks like at this time of the year, that's where I want the shading. Okay, we don't have to think about this in terms of just kind of strictly fixed panels. You could think about this in terms of some sort of a shading device that's going to close the, kind of close off that panel at that time of the year. Because what's going to happen is it'll change through the day. It'll change at different times of the year. So a little bit later on, I'm hoping to see these panels get a little more closed, and so those become a little bit more open. Yes?
I guess you can add a constraint that, or is that, the one very right bottom? That one is not there anymore. What? Can you add a constraint so that it might get thinner than? I think it has to do. I think it's because that 0 is kind of hanging around in there. I bet that's a 0 point, and the panels doesn't know what to do. So what we should really do is rescale this a little bit so it doesn't go strictly from 0. We put a little bump on it. Okay. So even in here,
let's just try that kind of as our own little experiment here. For example, on this opening, if I said that the minimum was going to be 0.05 or something like that, okay. Okay, that'll actually sort of, I think, put a minimum. But very good for catching that. I think that's just really the panel just doesn't know how to generate itself. Let's see how that's doing. There we go. Okay. Now, this biased it a little bit over here because now some of these ones are actually at 0.5, so they're capping out at 0.45. But again, we could sort of, if 0.5 was the minimum, and then we could scale it just on a value of 0.4, we could kind of rescale within there. But this is, in a lot of ways, this is very similar to the problem we have with like the sine waves, where you have this base point and then you have some fluctuation within that. So that, beauty. Okay, let us go ahead and pause there. Go ahead and take a break for 5 minutes. When you come on back, we'll keep on going with this, and we'll take it a little bit further in terms of saying, hey, not only can we adjust the size of the openings and stuff like this, let's give ourselves a little visual feedback. Let's put a little color into this to sort of help be able to interpret that real quickly. But hopefully you're starting to see, this is getting sort of interesting in terms of getting the panels to be able to respond to things. Yeah, whether it's the sun, we'll talk about some other conditions too. Okay, so let's go ahead and break for a second, and we will pick this up.